SwayamPrabha. Digital India. Educated India.
So, friends, in the course on production and operations management, we are discussing about production planning and control. In the previous sessions, we talked about aggregate production planning and materials requirement planning. We studied that aggregate production planning, we are trying to find out the detailed schedule of various production requirement, demand requirements, and based on that master production schedule, we have to release two types of orders. One is the purchase orders, second is the work orders. So, for the purchase order purpose, material requirement planning is one of the approach which was discussed yesterday in the previous session. In this session, we are talking about how to place the orders on the workshop for the purpose of producing the components and parts. So, this is a unit on scheduling and sequencing. There we will discuss about how the various jobs need to be planned in the shop floor. So, scheduling is the process of filling a production order into the available time of the machines and work centers and within a total time as promised in the delivery schedule. So, this definition suggests that our objective in scheduling is to see that all the machines and work centers are fully filled, and at the same time we should be able to achieve the due dates as promised to the customers. So, whole of the planning process we are talking about on one side the utilization of the machines, equipment and resources, and on the other side we are talking about timely delivery of the orders, order fulfillment, schedule adherence, or as per the due date or promised date, we should be able to meet the requirements of the customer. So, this scheduling is very important, though it is important in every manufacturing environment, every service environment, but scheduling is more important in job shop systems, because in job shop systems every job is a different job. The variety is very large, and each job requires different sets of processes, different set of sequence, and processing time may also be different. Car service centers, there also each car which is coming for a service at a service center need different requirements. Some are coming only for oil and service washing, some have some engine problems, some have some body and door problems, like that. So, job card is created for each and every job. Similarly, in ancillaries also, where you are having those standardized products in job shop and car service center, the product may not be standardized, but here in ancillaries we are having the standard product. Maybe you are producing 20 different types of gears, or you are manufacturing different types of motors, or it can be a OEM also which is manufacturing different sizes of electric motors starting from 0.0 horsepower to more than 300 horsepower, single phase, 3 phase, and all such kind of variety they are producing. So, in that case also scheduling and sequencing is very, very important. Scheduling and sequencing is less stringent, though it is also required in mass production system, where you are having very less variety, and throughout the planning period maybe you are running the same type of production. So, not many changes are required in that case, in case of mass production system. So, as I said, the key features of job shop, car service center or ancillaries are products are diverse, that is very important, and that make scheduling and sequencing a important aspect in managing these shops, and that means they are high variety we have to produce, and sometimes it is customer designed also, just like in car service center, in job shop also, tailor made items also. Product is not standardized, in sometimes they are very vast variety, and in many cases it may be custom designed. Then second important parameter of this which facilitate, the process steps are uncoupled, they are not integrated together, they are independent in nature. We are using a process layout, one type of process is at one place like that, and orders can follow a multitude of paths. So, that you can have all the flexibility, any job can move use any resource depending upon the availability and the process requirement. So, lot of flexibility is there in the manufacturing system, unlike mass production system or product based production systems, where machines are arranged according to the requirements of product. But here in this case it is a process based systems, where all processes are not linked together, connected together, coupled together, rather they behave independently, and we are having the complete flexibility or routing the different jobs through the shop. Let us see an example of a car service center. What happens typically in a car service center? Suppose this is my car service center area, this is your in gate, and vehicles are coming and they are getting parked here, and then service engineer will come, he will prepare the job card. Service engineer will come and he will prepare the job cards for these jobs. In the job card he will ask what services you need. Depending upon the services, he will have a trial also, and based on that he will decide together, both the customer and the service engineer decide together what jobs need to be done. Maybe if some customer has a financial constraint or he do not want to spend more than a certain amount, then it is negotiated that which are the services which can be should be carried out. So, once this job card is created, then maybe if we can say this is the engine area where the engine related work is carried out, this is another area where wheels related work is carried out, this is engine related work, this is wheel related work, and this is the area where other than engine, clutch and other clutch, brakes etcetera is carried out, and there may be a facility where oil change facility is there. Then there are a unit which looks into the air conditioning repair etcetera. There may be a separate body shop also. There may be a body shop separately which do the denting, painting, and then there may be a washing area, and then from there it is going out to the customers. Now, first job may require a different requirement. The job number 1 may go to engine, from engine to oil work, and oil work to washing, and may be going out. Whereas, another job may require a different kind of a requirement, where it has come only for services. So, it will go to here services and services to washing and washing to out. There may be a third job, which has altogether another set of requirements. Maybe this job is first going to the body shop for any denting, painting, door repair or something like that, and then it is going for wheel balancing, maybe some kind of a accident or something, then wheel balancing, and then going for washing and coming out. There may be another job which require only some other operations, and then washing and then going out. So, like this. So, what we are observing is large number of jobs are there, each job is of a different type, and these processes are flexible. You can route them through any of these processes, there is no constraint in that way. So, that is a typical example of any service center, which is where the large variety of jobs are entering into the system, and for each job when he is issuing the job card, when the job supervisor is issuing the job card, he is saying that okay, you come at 4 p.m. to collect the job. He for this guy he may be saying that okay, you come next day at 11 a.m., like this. So, due dates are also given to the customers when the jobs are booked. So, now it is production planning and scheduling will come into the picture. You have to schedule the various jobs throughout the shop in such a manner that all jobs are able to complete by the due date, and number 2, all the facilities are fully occupied. There should be a good utilization of these resources. So, that is the car service center. Let us take another example. Again let us draw a manufacturing unit. Okay, you may have a line which is here orders are received of you may be having different sizes of motor. Here the variety is the product is standard products. standard products. Maybe you are producing 40 different types of motors, types of electric motors, AC motors. Okay, maybe DC also, size is from 0.5 horsepower to more than 300 horsepower, and there may be a single phase and 3 phase motors and like this. So, for each type of product you are having certain quantity to be produced. Let us say for example sake you have to produce let us say 5 types of motor, you have to produce 200 units of this, 300 units of this, 100 units of this, 400 units of this and 100 units of this in a planning period. Now, each of these motor has to pass through a stator and then binding. This is a stator and maybe some kind of a binding is required. Okay. Then there is a rotor line where you are doing all kind of a machining etcetera, and then there may be another machining line where you are doing end plates and other components, and then there may be some kind of a assembly area where these motors are assembled, and then testing and then dispatch, testing and then dispatch. So, like this. So, there can be such kind of a system. So, here also you will find that each line is used for different types of motor, and assembly is possible only when all the components are available. And you may find if the scheduling is not done in a good manner, if the scheduling is not very good, you may find that there is a mismatch of component. Stator is available, rotor is available, but some end plates are not available, some other components are not available, some hardware which is required to assemble that may not be available. So, due to that you are not able to dispatch your product, you are not able to assemble the product and test and dispatch it. So, that is the role of scheduling here. So, you have to see that, ensure that all the components, because it is going in sets. So, you have to ensure that all the component parts which are required to manufacture a motor, they are scheduled in such a manner that end product is manufactured. Again, each of these has a delivery schedule. So, they are manufactured and they are made available for dispatches as per the delivery schedules. So, that is the kind of thing, and this is, we can call it this is a case of original equipment manufacturer, or same case we can discuss for the ancillary also. Ancillary, let us say for manufacturing different types of gears for OEMs. They are manufacturing gears for OEMs, several OEMs, automobile manufacturers, you are manufacturing different types of gears, maybe you are manufacturing 20 different types of gears of different sizes, different purposes and other things. So, there so different lines are there, different machines are there in that process also. So, we have to do the scheduling in such a manner that again in manufacturing of a car or bike or anything, you need a one set of gears, it should be complete. It should not happen that one type of gear is not there. So, that will lead to that you are not able to assemble the engine or car or bikes. So, that is a very important function in production planning and control, that is scheduling. We should schedule our jobs in such a manner that there is a good utilization of all my resources, machine and equipment. At the same time the jobs are make ready with the as per the due date. There should be another important performance measure is there should be minimum work in process on the shop floor. There should be minimum work in process on the shop floor, so that you are having the space requirement should not be very high. Now, coming to the objectives of scheduling, though we have discussed maximum utilization of plant, equipment and other resources, maintaining a uniform level of manpower and other resources, that is also very important. You should not be hiring and firing the worker, and ensure the timely delivery of the orders, and these objectives are achieved by information of the work orders and promised due date. I should know what are the various work orders and what is their promised due dates, information about the capacity of the system. So, these are the input parameters for scheduling. Information about the capacity of the system, information about the available workforce, information about the availability of material, any spares required in a company, or various types of casting required in a gear manufacturing unit, or various types of other components are required, raw material required in different setups. So, we should know that in a car service center, you should know the availability of spares also. Then information about planned maintenance, if there is any planned shutdown, or the frequency of breakdowns also. So, you should know that what is the availability of various equipments, various facilities, machines and equipment, and based on that we can do our scheduling. So, the various aspects in scheduling are, first and foremost is the loading. I know that these are the jobs which I have to produce A, B, C, D, like this I have to produce the jobs. Then I should earmark that which particular machine is going to be, or resource is going to be used, allocation of resources to the various jobs. So, that is the first aspect in scheduling. I must earmark a particular resource, machine, equipment, manpower, or if it is a skilled worker required for engine purpose. So, I must earmark a resource for a particular job. It is just like in our academic system also, in a particular semester, if we see that in a university system or in an institute system, every semester or trimester we do this kind of a planning. Certain number of subjects are to be taught as per the curriculum. So, these are the jobs in a way, subjects to be taught. Okay. These are the nothing but jobs to be performed in the coming semester, and then you are having various resources in the form of faculty, in the form of laboratories and other things. Then you are earmarking that subject number this will go to this faculty, subject number this will go to this faculty, and if there is a lab, this will go to this particular lab, and so on. So, that is nothing but loading. We are loading the various facilities, various resources to the jobs. So, this is matching of existing and expected orders with the capacities. So, we are matching the existing and expected orders with the capacity, assigning orders to specific facilities, operators and equipment. So, we assign these orders to different machines, equipment, laboratories, faculty members, operators, equipments, etc. In the restaurant also you will find there may be 10 waiters in the restaurant, but a particular table is attended by a particular waiter. So, that is what nothing but loading. So, the waiter is assigned to the particular table. In certain restaurant it is fixed also, certain tables are assigned to certain waiters. So, that is also there. So, that is the first aspect in scheduling. First thing, you have to load the various facilities, operators and equipment for different work orders, jobs, etc. Second is the sequencing. Determine the sequence in which jobs are to be processed. Suppose to a particular machine, you have assigned 5 jobs A, B, C, D and E. Okay. Now, you have to decide in what sequence. It can be sequence can be first come first serve, that means in the same order in which they are coming, or there may be other priority rules also which we will discuss. So, we have to decide, determine the sequence in which the jobs have to be processed based on the priority of the jobs and the utilization of the resources. So, we will decide various performance measures we will consider here. So, that is the second step. Once you have decided, you have loaded the machine or a particular work center, several jobs are assigned to it to be performed in the given planning period. Then we have to determine the sequence in which these jobs to be processed. So, idea is we should meet the due dates, idea is the utilization of the equipment should be good, and also there is an idea that the flow is smooth and we are able to complete all the 5 jobs in minimum possible time, that is called make span period. That means, idea is to minimize the make span. Minimize the make span. Make span is start of the first job to the finishing of the last job on this particular machine. So, that is the kind of a make span period, we have to minimize the make span period. Then come the dispatching, issuing dispatching list to each work centers, authorizing the actual performance of the job schedules. So, that is the third stage. Once you have done the sequence also, you have done the load also. Now, it is the actual authorizing the work centers or resources to perform the job. So, third issue is dispatching. Then we have to do the follow up also. To gather this, gather this, to gather these three activities together, if we put a time frame to them, at what time a particular job will start on a particular machine after dispatching based on the loading and sequencing. If we can say that if there are machine 1, machine 2 and there is a job A, B, C, we can say that job this will start at 0, it require 15 minutes to complete, it will be completed on 15 minutes. Then it will go to the machine 2 and there it require 10 minutes. So, this will be completed at 25. So, this is the start time, this is the finish time, this is the start time, this is the finish time. So, this type of information is called the schedule. So, that means you have prepare a schedule just like a railway timetable. Train will run on a route, we know that at what time it will reach at a particular station. So, that is the schedule is nothing but railway timetable, just like for each job as well as for each machine we are having a timetable, at what time job will start on a particular machine, at what time it will finish, at what time it will go there and like that. Similarly, if I take now next job can start at 15, let us say it is required 25 minutes and it will be free at 40. Now, next job cannot start at 25 because B will be available only at 40 and it require let us say 7 minutes. So, 47 like this. So, we have to see the higher number of these two. When the machine is ready at 25, machine is ready at 40, the job is available for machine 2. So, like this. So, in this case you will find that machine 2 is ideal for 15 minutes. The machine 2 is ideal for 15 minutes. So, we have to do the scheduling in such a manner there is minimum waiting time for the job and there should be a minimum. On the other hand, let us say if B itself another case of B 15, let us say this job time is let us say 5 minutes only, it is ready at 20, but the machine is not available, you can start this job only at 25. So, in that case also now in this case job is ideal for 5 minutes in between. So, that is the schedule which we have to prepare, which is a combination of loading, sequencing and dispatching and then converting them into a time frame, giving them a time frame also, that is called scheduling. Then after doing this loading, sequencing, dispatching and scheduling, then we have to do the follow up also, providing input output control on all work center. We should see that machine is getting the job as per the schedule, it is able to produce as per the schedule. Reviewing the status of the job as they are processed in the system. We will take the help of Gantt chart for this purpose. We will draw the Gantt charts, very popular charts. We will use the Gantt chart to review for the purpose of follow up also, and then based on the follow up, if there is any expediting required or if there is any critical order or late order is running late. So, we can add additional resources or we can rework out something to see that and the job is prepared as per the due dates. Then there is a revision of the schedules also due to if the material you are not able to get, non availability of spare part, non availability of the certain component parts, castings etcetera, or some material, some fastener hardwares. So, or there may be some delays in execution because of maintenance, because of some power failure or some other issues also, there may be several issues in the system. So, for keeping that in mind, we have to revise the system also. And then obviously, we should see, we should have the dashboard also to see the efficiency, utilization and productivity of the workers and machines at each work center. So, these are some of the activities which are part and parcel of scheduling process. We have already discussed what are the various input information required. So, first is the physical capacities, how many machines, how many human resource, machine hours, man hours I am having with me, and then what are the performance standard, how many units they can produce in 1 hour, how many units they can produce in 8 hours, what is their performance standards. Generally standard times, we are having the standard times to perform different jobs. So, based on that we can calculate their performance standards, and then what is the unit of the scheduling. whether it is a day to day schedule or week to week schedule, again depend upon different situation. Like in a car service system, it is more a day to day schedule. Every day in the morning you are booking the cars and then you are delivering most of the cars on the same day in the evening or as per the requirement, as per the job and work content. Or there may be weekly schedules also for your OEM manufacturing electric motors. Daily schedules are not possible here, electric motors. So, there we may go for a week to week schedules also, and it depends upon the nature of the products, and the more important is the manufacturing cycle. How much time is required when the material entered into the system and when the final product is dispatched. Your scheduling unit should be greater than this time. If it takes 3 days when the material enter and when the finished goods is out. So, your scheduling period should be more than 3 days. So, generally week to week schedule can be prepared for such kind of item, but in this case car service center you can have a daily schedule, because your when car enters and out, it is maybe few hours only. Then you have to see what are the effective capacities based on the working hours and downtime. You are working 8 hours a shift, you are working 12 hours, or you are working 2 shifts or 3 shifts, depending upon that. And there may be some rush orders also in a car manufacturing system also. There may be certain orders which you have to expedite, or which you have to, which are coming in between also. So, you have to consider, same is true in the any company, in OEM manufacturing also, or in every system you are having certain orders which are rush order, which will have short due dates, the priority is to be given to them. And then there may be overlapping of operations also. 2 or more operations can be carried out simultaneously. One worker is working on the left side of the car, another is working on the right side, or maybe you are doing 2 or 3 activities together. Certain parts are offloaded, dismantled from the vehicle, and they are being done separately. In the meantime, you are doing some other aspects on the main vehicle. So, there may be overlapping of operations also, where 2 or more operations are carried out simultaneously. So, we should have that information also. So, some of the examples in a hospital, you may require the scheduling of the operation theatre, very important resource and very expensive resource. We want it should be fully utilized. So, various patients they may have a different time requirement. Then there is a schedule of the doctors also, who is going to operate, nursing staff and other paramedical staff and the anesthesia person. So, depending upon all these resources which are required in operating. So, you have to create the schedule for the operation theatre also. Okay. Similarly, the nursing schedule, security, maintenance staff, etc., clinical tests, etc. So, in a hospital, that is general time is given to you, appointment is given to you for that. In a educational institutes, classrooms and audiovisual equipments and faculty timetable, they are examples of scheduling. In a car manufacturing, you have workers, scheduling of the machines, scheduling of jobs, purchase of material. So, these are some of aspects of scheduling. In a restaurant, chef, waiter, bartenders, you have to schedule this human resource. Delivery of the fresh foods, you have to schedule that also, and if there is any entertainment events or something, you have to schedule that also. Similarly, in airlines, flight crews, catering, gate, ticketing personals. So, human resource we have to schedule. Then check-in of the passenger, baggage drop, etc., airport services, maintenance of the aircraft. So, you have to schedule the maintenance of the aircrafts also, because of the limited facilities available there, and then you have to see the timetable also, each at what time flight will depart, at what time it will arrive, and how much time is required in takeoff and landing, and all such things we have to design in our scheduling. There are 2 types of scheduling we can consider. One is called forward scheduling. Forward scheduling is based on the due dates, based on the based on the when the material is available, we can start it. So, forward scheduling starts as soon as the requirements are known. Produces a feasible schedule, though it may not meet the due dates. Frequently results in build up of work in process inventory. So, these schedules, as and when material is available, we start the working and we keep on doing it, and but may results in, because demand, it is not directly matched with the demand, generally used for make to stock items, generally used for make to stock items. Then there is a, which is most popular, is backward scheduling based on the actual orders and due dates. So, based on the due date and the actual order, we plan the last activity and then move backward to plan the other activity, other processes. So, the last activity is planned first and scheduled first, and based on that we schedule the other previous activities. So, backward scheduling begins with the due date and schedules the final operation first, whereas in this case the first operation is scheduled first and then we keep on moving the material. It is more like a push system, whereas it is more like a pull system. Schedule is produced by working backward through the processes. Resources may not be available to accomplish the schedule. So, that may be a difficulty in this case. At certain places maybe the demand is more and resources are bottlenecked. So, job has to wait in that case. So, that generally these approaches are combined together in a they are not used in a more in a pure manner, rather they are used in a mixed manner. You first do the backward scheduling, see that it is possible if there is any bottleneck, or then based on the availability of that resource we work forward also. So, it is a first work based on the due date backwardly, and then if there is any bottleneck or any constraint, keeping that in mind, again work for forward manner. So, like this. So, are combined to develop a trade off between economical and feasible schedules and customer due dates. So, we have to see that they are feasible and at the same time we should keep in customer due date. Maybe at some places you may have to shift the due dates also because of the constraints or infeasibility of the backward scheduling. Performance measures very important. In job shop systems or in scheduling, very important performance measure is minimize the make spend time. The make spend time is the time between finish of the last job to the start of the first job. Like I said that if you have to perform 5 jobs on a manufacturing system where you are having machine 1, then machine 2 and then 3, and jobs are moving in this manner. So, the start of the first job here till the last job is moved out from this. So, this time total time is called make spend time, time between finish of the last job to the start of the first job. That is the first performance measure, very important. Second is the meet due dates. We should have minimum lateness, minimum number of tardy jobs, late jobs. So, second important objective is meeting the due dates. Third is maximize utilization of the facilities. Facilities are expensive, whether it is a human resource, manpower or machines, equipment or even space also. So, we should see that maximum utilization of the facilities. Minimize work in process inventory. Again, more the work in process inventory, more space is required. Minimize customer waiting time also. So, the waiting time to the customer should be minimum. We should try to do the job in as minimum time as possible and maintain the level workforce. There should not be too much hiring and firing of the workforce. So, these are some of the performance measures which we are going to use in the scheduling activity. Though the problem is very complex, as we have seen at a car manufacturing unit, car service center, we have seen at a ancillaries manufacturing gears or OEM manufacturing electric motors, etc. The case are very complex. They are, we can say that it is a N jobs and M machines. But for the sake of understanding here, we will take some examples, small examples, and based on that we will try to develop the algorithms. When these algorithms are combined together, we can very easily develop the method, develop the scheduling for the N jobs and machines of any complex environment. Any complex environment we can develop, and we will try to understand some algorithms here, and these algorithms can combine together, can be used for complex kind of a jobs, complex kind of a scheduling system. So, we will first start with a very simple case of n jobs and 2 machines, n jobs and 2 machines, then we will go to n jobs and 3 machines, then we will take a case here we are going to use the apply the Johnson's rule. Here we are going to apply the Johnson's rule. Here we are going to apply the modified Johnson's rule, modified Johnson's rule, and then here we are going to apply the Jackson's rule. And then we will see that with the help of spreadsheets, we will see the n jobs with due dates. These 3 first cases are without due date, where we do not have the due date, but there is a constraint that each job is first go to machine A, then go to machine B. Each job is first go to machine A, then to machine B, then to machine C. Whereas, in this case all possible combinations are there. There are certain jobs which require only machine A, there are certain jobs which require only machine B, there are certain jobs which first A, then B, there are certain jobs which first B, then A. Then we will also study one case where you are having 2 jobs and n machine, we will apply the graphical method here. We will apply the graphical method here. We will also study one more approach here, which is called assignment model, where we are having n jobs, m machines, and we are doing the loading of that. That case also we are going to discuss how to load the n jobs on m machines, so that the total time required to complete the jobs is minimum. So, that is a loading issue which we will do with the help of assignment model. We will apply the assignment model, which is again a optimization model in operation research. It is a optimization model in operation research. Model in operations research. So, any book of operation research can be referred for this particular purpose. So, these are some of the exercises which we are going to do here to understand the nitty-gritty of the scheduling activities. And another thing which you have to understand here, this when I said Johnson's rule or modified Johnson's rule or Jackson's rule, or whether it is a graphical method, they are not optimization method. Rather they are called heuristics. When I say heuristic, they are also a modeling technique, heuristic models. In heuristic models, they are based on the rule of thumb. Certain practitioners have used that particular algorithm, that particular procedure, and they found that by and large they are getting good answer. There is no guarantee of optimization in these methods, but answers are the results or are always very good and very close to the optimal solution. But number 1, the methodology has no mathematical or scientific base, and number 2, the results coming out of the heuristic method cannot be, we cannot say this is the optimal answer, but most of the time it gives a good answer. The advantage of this is they are very easy to apply, not much computation is required. That is the strength of these methods, very less computation is required in applying the heuristic methods. So, let us start with the first activity, n jobs and 2 machines, and applying the Johnson's method. Sequencing of n jobs on 2 machines. Work with 2 or more jobs, we are having, like in this case we have considered 5 jobs A, B, C, D and E, and they are, we have taken 2 machines, machine 1 and machine 2, and each job is first going to machine 1 and then going to machine 2. And our objective is to minimize the total production time, and the ideal time, or we call minimize make span time. We have to complete all the 5 jobs in the minimum time. we have to complete all the 5 jobs in minimum make span time. Okay. So, that is the objective here, and we will use the Johnson's rule for this purpose. Let us see, let us understand the Johnson's rule. The rule is very simple. Let us understand the Johnson's rule. The rule is very simple. In this list of the try to find out the least number, or to start with, there are 5 jobs, make a box and divide it into 5 sections. Now, try to find out the minimum number in this list, in this matrix. The minimum number is 3, corresponding to job D. So, minimum number is 3 corresponding to job D. If this number is in the second column in the machine 2, then schedule this job as late as possible. Schedule this job as late as possible. Repeating, find out the minimum number in this matrix. The minimum number is 3. It is corresponding to job 3, job D. See that if it is in the against the second machine, then assign it as late as possible. If it is machine 1, assign it as early as possible. Once a job is assigned, strike out off from the future consideration. Now, see what is the minimum number. We are having 6 here. The next minimum number is 6 here. There is another 6 also, we will take that also. The next is 6 here. This is corresponding to job C, and this is in the first column against machine 1. So, C to be assigned as early as possible. C we are going to schedule as early as possible. Now, we will strike off this. If there is a tie, we can choose any one. Then next minimum is job, this 6 corresponding to job A. Now, this is in the second column against machine C. So, job A to be assigned as late as possible. Now, once you have done that, eliminate that also. Now, we are left with B and E. Now, the next minimum number is 10. The next minimum number is 10. So, 10 is against job E and machine 1. So, E to be assigned as early as possible, and now left is B. So, like this. So, this is a very simple algorithm of a Johnson's rule. See in the matrix the minimum number. If it is in column 1, assign it as early as possible. If it is in column 2, assign it as late as possible. So, that is a simple rule, and based on that we can find the. So, my sequence of the jobs. So, I have sequenced the jobs. In the sequence I will first perform C, then I will perform E, then I will perform B, then A, and then D. So, this is the sequence in which I am going to take up the jobs. Each job will first go to machine 1 and then it will go to machine 2. A very simple algorithm. Let us see in the stepwise manner also. So, what is required to apply the Johnson's rule? List all jobs and time for each machine and work center. So, we have listed all the jobs here A to E, and we have also noted down their times on machine 1 and on machine 2. Choose the job with the shortest activity time. Choose the job with the shortest activity time, that is 3. If the time is for the first machine, schedule the job as late as possible. If that time is for the first machine, schedule the job as early as possible. If it is for the second machine, schedule the job as late as possible. So, now this is for the second machine. So, schedule it as late as possible. Once the job is scheduled, eliminate it from the further consideration, and then again repeat it. The next minimum is 6. So, C to be scheduled as early as possible. Next minimum is another 6, A to be scheduled as late as possible. Next minimum is 10, E to be scheduled as early as possible. Next is this to be scheduled here. So, like this. So, repeat step 2 and 3 working towards the center of the sequence. So, we work towards the center of the sequence and we are able to sequence all the jobs in which it is to be go. So, very simple rule, very useful rule, that is called Johnson's rule. Now, let us see what is the total make spend time. Let us see the total make spend time of this particular schedule. I have prepared this working table. So, now I have listed the jobs in the sequence C, E, B, A, D. So, I have listed them C, E, B, A and D, and then I have also noted down the time. The time for C is processing time on this is 6 and then 8. 6 and 8 is the processing time for job C. Just note that for the job C, the processing time on machine 1 is 6, on machine 2 is 8. Then see the job E here, the processing time are 10 and 14, processing time are 10 and 14, okay, like this. Now, let us see in the same manner the job B has 12 and 11, B has 12 and 11. Then see the A has 13 and 6. So, we have copied here. D is having 9 and 3. So, we have noted down here. Okay. So, this is how we have arranged the jobs in the sequence, in the optimal sequence, which we have identified using the Johnson's rule, and now we are trying to find out the make spend time. We can assume that our factory starts at time 0. So, the C can start at time 0, it requires 6 unit of time. So, it will be completed at 6 time clock, and then it can go to the machine 2 at 6, will take 8 units of time and will be finished at 14. Okay. Now, job 2, it can start on machine 1 at 6, because first job is getting completed at 6, it can start at 6 and end at 16. So, now we have to see the minimum of these two numbers. I have to see the higher of the two numbers. Job 1 is ready at 16, machine 2 is ready at 14. So, I have to see a time when both are ready. Repeating, job E is ready at 16 minute of time, machine 2 is ready at 14 minute of time, both are ready at 16. So, I will write 16 here and 16 plus 14, 30 here. So, again I will continue this 16 plus 12, 28, and here I will take 30 and 11, 41. Okay. Here I will take 28 plus 13, 41, and here I am taking 41, both are same, I am doing it 47. So, here I am doing it 41 plus this 50, I will start at 50 and complete the task, all the task at 53. So, total time required to complete the all the 5 jobs is 53 time units. It can be minutes, it can be hours, depending upon the nature of the time scale which we are having. Okay. So, the total make spend time is 53 minutes, let us say for the time sake. 53 minutes are required to complete all the 5 jobs on 2 machines, machine 1 and 2, and each job is moving from first to machine 1 and then to machine 2. So, like this I have written in a print manner also for your convenience, like this. Now, 53 is the optimal time which we have with the help of optimal sequence. Let us see what would have been the time if we are doing in the same sequence in which jobs are available, have been made available to me. If the sequence is A, B, C, D, then we will calculate how much is the improvement in the efficiency by following the Johnson's rule. Job A we can take from here only 13, and job B 12, job C 6, job D 9, job E 10. Similarly, here I can take job C at 8, job A at 6, job B 11, job D 3, and then job E is 14. So, let us check. A is 13 and 6, B is 12 and 11, C is 6 and 8, D is 9 and 3, E is 10 and 14. Now, I can again find out the make span time by following the sequence of A, B, C, D and E. So, again we will start at 0, we will finish at 13, we will start at 13, we will finish at 19, we will start at 13, complete at 25, we will start at 25 here and finish at 36. We will start at 25, do it at 31, but we will start at 36 and 44. We will start at 31, 40, we will start at 44 and 47, and this is 40, this is 50, this is 50 and this is 64. So, if we are not following the optimal sequence, the total time required will be 64. The total time required will be 64. So, this is how you can now very much appreciate the advantage of applying the Johnson's rule. By applying the Johnson's rule, I am able to reduce the total processing time from 64 time units to 53 time unit. Let us calculate the improvement in efficiency by applying this. So, this is again I have written in a type manner also for your convenience, for your purpose. So, earlier it was taken 53 units. If we follow the sequence A, B, C, D, E, it will take 64 time units, but if we use the optimal sequence as per the Johnson's rule, then it will take 53 time units only. What is the improvement in efficiency? 64 minus 53 divided by 64 into 100. So, there is a 17.18% reduction in the total make span time, or improvement in the efficiency is 17.18. I am able to complete the task by consuming 17% less time as compared to if I would have followed the sequence in which jobs have entered into the system. So, that is the advantage, that is the application of a Johnson's rule. Now, we can draw the Gantt chart also for these jobs and machines. Let us draw the Gantt chart also for these machines to see that. So, we will draw the Gantt chart for optimal sequence which we have identified. Machine 1, it will start at 0 up to 6 minutes. I am doing little bit approximate. So, we are doing the job C on this, then 6 to 16. Let us first do the machine A, 6 to 16 we are doing E, then 16 to 28 somewhere. I can mark it as 16, I can mark this as 28, you can do on a graph also. So, this is B, and then I am doing up to 41, up to 41 I am doing A, and then from 41 to 50 I am doing D. So, this is the time when these are, we can say that like this. Let us see what happens to machine 2. Let us happen to machine 2. It will start at 6, it will start at 6. So, during this time the machine is ideal, during this time the machine is ideal. Okay, there is no work on this machine. It will start at 6 and finish at 14. So, finish at 14. So, during this time it is processing job D, and then it will start at 16. So, during this time also the machine is ideal. So, not having any work at 16 to 30 it will. Okay. After doing this 30, now there is no idle time, it finish at 30. At 30, small correction here also, 30 is here, we have to draw the 30 here, here is the 30 when we have to draw. So, 30, now here we are taking the job B and 11 41. So, this is the time when B is going to be processed. Okay. And then 41, there is again no idle time, it finishes at 40 and started at 41 itself. So, there is no idle time. So, we can take it at 40 and complete it at take it at 41 and complete it at 47. So, that is my job A. Okay. And then again there is a idle time of 3 units. So, if this is 47, I am starting at 50. So, during time again the machine 2 is idle and 53. So, whole job is completed by 53. Okay. So, this is my job number D. So, this is how it looks like on a Gantt chart. There is no idle time on the machine 1 because it need not to wait, it can process the jobs, but machine 2 has to wait if the jobs are not released from the machine 1. So, these are the certain time slots like 0 to 6, then 14 to 16 the machine is ideal, then there is the machine is also ideal from 47 to 50. So, there are 3 intermediate blocks when the machine 2 is ideal, and the total time required to complete all the 5 jobs is 53 time units. So, this is how we have studied the Johnson's rule. So, this is how we have conducted the Johnson's rule. So, this is how we have prepared the Gantt chart, and we get to know that there are 3 places when the machine 2 has to wait. One is from 0 to 6, then 14 to 16 and then 47 to 50 time units. In the same manner, we can we can develop the Gantt chart that will help you in the practice also. You will get the and we can compare this Gantt chart with the Gantt chart of the optimal sequence. So, in this case 0 to 13 is my job A. Let us first talk about machine 1. 0 to 13 is my job A, then 13 to 25 is job B. This is 13, this is 25 is job B, and then 25 to 31 is job C, 31 to 40 is job D, and 40 to 50 is job E. Okay. Now, let us see machine 2. Machine 2 will start at 13. Let us change the color also. Up to this time the machine is idle, there is no work. Okay. The first job is reaching to machine 2 at point 13, and then it will take 6 unit of time and complete by 19. A is completed by 19, and then again it has to wait till 25. Next job is available only at this point. So, again this machine has to wait, and at 25 it will start work and will finish at 36, will finish at 36. Okay. So, this is job B, and at 36 there is no idle time, job is available. So, 36 it will start and complete at 44, complete at 44. So, that is job C, and then it will start at 44 and complete in 3:47. Again it has to wait for 47 to 50 and then 14 units of this, that is 64, that is E. So, this is how you will find that it has taken 64 time units on the Gantt chart to complete the job, whereas the previous case we are able to do it in 53 time units. Now, if you see closely why, what is the this is happening, just to develop the intuition and foresight about this. What happens here in this case? What we have done is we have done the smallest job on machine 1 first, so that it is made available to the machine 2. So, we have identified the job which is having the smallest time on machine 1, we have scheduled it first, so that machine 2 is ideal for the minimum possible time. So, there is nothing as such, it is a very simple logic which has been applied. You take up the smallest job on machine 1 and make it available to machine 2 as early as possible. So, we have kept the job which is having the smallest time on machine 1, that is scheduled first. And similarly, the last job which we have kept on machine 2 is such that which is having the smallest time. So, that once the machine A has completed it should not take much time. So, the last job on the machine 2 is the one which is having the shortest processing time on machine 2. So, this is where the algorithm is. Select the job which is having the smallest time. If it is on machine 1, it is schedule it as early as possible. If it is on machine 2, schedule it as late as possible. So, that is the simple algorithm which has been simple logic which has been applied in Johnson's rule. I hope you are clear about the various steps required, the importance of the Johnson's rule, how it helps in improving the efficiency of the system, reducing the idle time of the machines, reducing the make spend time of this, and you should also be able to understand the logic also on what logic this rule has been developed. Logic is very simple, keep the first job on machine 1 which need the smallest possible time, so that it can be made available to the machine 2. On the machine 2, the last job should be such that which require the minimum possible time, so that after it take very less time once the machine A has completed its tasks. So, this is all about the Johnson's rule. In the next session, we will talk about the modified Johnson's rule, where rather than taking 2 machines, machine 1 and 2, we will take 3 machines, machine 1, 2 and 3, and same type of algorithm is there with some small modification. We will apply the modified Johnson's rule for n jobs and 3 machines. So, with this we are closing this particular session. Thank you.